So this is a sample study guide for chapters 4 and 5. So question 1 is asking you to solve by graphing, and it gives you two inequalities. So for inequalities, what you do is you graph the boundary line. So the y-intercept -1, the slope is 1/2, so rise 1, run 2. Reverse it just to get a few more points. In XYZ, you just use the 2 points that make the line with the line tool. If you're doing it by hand, you have to put as many points to give yourself a good guiding line. We're going to do a dashed line because it's only less than, it's not equal to. And then we have to figure out what side to shade. So I'm going to test the point 0, 0. So I'm going to plug in 0 for y and for x. 0 times anything is 0. So I have 0 minus 1 there. Is 0 less than -1? The answer is no. So you're not going to shade that point. Please interrupt me if you have any questions or want clarity on anything. And then for the second one, we're going to start at +3 as our y-intercept, and we have a slope of -3/2. So we're going to go down 3 over 2, down 3 over 2. We can go up and left. That's like putting the negative on the denominator. This one's going to have a solid line because it's got the equal to part. I'm going to test 0, 0 on that one. So I'm going to plug in 0 and 0 for the x and the y. Anything times 0 is 0. So here I have a 0 less than or equal to 3. 0 plus 3 is 3. And that is a yes. So this time I'm going to shade the 0, 0 because it was a solution for that inequality. And the solution to the system is the solution to both where they overlap. So the solution to the system is this region here. So you'd want to darkly shade that or highlight it, make it very obvious that just this quadrant right here has your solutions for the system. Number 2 is solving by graphing. So we'd want to rewrite this top one in y equals mx plus b form to help us graph. Or this one, because 1 and 2 go into 4 evenly, you could use the intercept method. So if x is 0, then y would be -2. And if y is 0, x would be -4. Now I'm freehanding that, and the issue with freehanding it is, what if I'm slightly off and the point of intersection between these two isn't great? So you could be a little bit more accurate by recognizing the slope is 1, 2, 1, 2, 3, 4. So it's down 2, right 4, or down 1, right 2. So you can get a few more points. So you can see I was fairly accurate, but maybe it's even further, so I'll continue it as far as I can. And you can see I kind of got off a little bit on that one because I was, again, freehanding. I kind of did that on purpose because I wanted to emphasize that you really need to do as many points as possible if you're doing this freehand. If you're using XYZ, the tool for it just wants 2 points. Alternatively, instead of using the intercepts, you can also rewrite this. So you'd subtract x from both sides and then divide by 2. To divide both terms by 2. So it has a y-intercept of -2 and has a slope of -1/2, so down 1, right 2. So then this one is start at 5 on the y-axis as your y-intercept, and then rise over run, so up 2 over 3. 2 over 3. Down 2 over 3. Down 2 over 3. It looks looks like I found my intersection. 1, 2, 1, 2, 3. And for systems of equations, it's the point that would work for both, the x, y values that work for both equations. And so this point right here, which is at -6, 1, is the solution. It is the point that would work for both. It is the solution of both lines. So there is inequalities. That's 4.4. Here's 4.1, section 4.1. And then 4.2, it was on solving systems of equations using elimination or substitution. And then there was also for systems of 3. So ideally, we have equations where when we add them, they just eliminate automatically for either x's or y's. But most of the time, we'll have to multiply one equation or both by something to make the x's or y's eliminate. You want to go with the smallest numbers. That way the math is just a little bit easier. So I could get these to be 6 and -6. That's the lowest common multiple. Or I could get these to be 2 and -2. That would be the lowest common multiple for the y's. So I'll go ahead and just multiply this by 2. So I'll have 2y and -2y. That allows me to eliminate because they're opposites. Add these together, they eliminate. These become 6x and 2x is 8x. And -8 dividing by 8 gives me x equals -1. I plug that into either one of these because, again, it's just the x coordinate. We have to find that y location. It would have to be true for both. So like here, I could plug in the x of -6 and I'd find the y. It would have to be the same line, whether I use the green line or the blue line. So I can plug it into any of my equations or even this equivalent one right here, whichever one looks easiest to you. I'll do the top one here. So I'll plug in -1 for the x. So it's called back substitution at this point. We'll add 2 to both sides now. And then divide by 2. Y equals 3. Your answer is an ordered pair, x comma y. Number 4 is one with fractions. If you get one with fractions, I recommend that you do the LCD method to clear the fractions. For example, multiplying by the lowest common denominator value of 2, I get this expression, and by 4, I would get this expression. Then from there, I can figure out how to eliminate the x's or y's. Once you have integers, it's a little bit easier to work with. Now, you could also be kind of strategic and realize you would have needed, here would have been x and here would have been x, and so you could have done a -4 or a -2 and taken care of that all at once. But often we don't see that until we're at the integer stage. So on this problem, I got rid of the x's. The last problem, I had gotten rid of the y's. So it doesn't matter which variable you get rid of first. Do the one that's easiest, the lowest common multiple of the coefficients of either x or of y. So if you find y first, then you plug it in for y and you solve for x, the next one. Just make sure you're plugging in for the value that it represents. For a system of 3 equations, you pair up 2 of them at a time, getting rid of the same variable. So if I notice that I have opposites of y's here, I might think, oh, it's easy for me to get rid of y's. And so that's what I did. And I paired up B and C, these two y's, and then I paired up A and -2, let's see, A and 2 times my B to get rid of y's again. I could have gotten rid of z's fairly easily as well because they're already opposites, but I just chose to get rid of y's. But notice I got rid of y's here so I had to get rid of it for the next pairing. I can't get rid of y's and then z's or y's and then x's. It has to be the same thing that you're eliminating. So you get a system of two equations. I call it D and E with the same two letters left over. In this case, x and z. That way you have a system of two and can solve it like we did earlier. So I'm looking at these two. My x's are the same. To make them opposites, I just multiplied all of these by -1. Wrote it down here. Therefore, my x's canceled, found z, plugged it back in to either of these to find x, and then plugged it into any of these to find my y. So that is the systems of equations. There is Gaussian elimination and Cramer's rule that can be used to solve systems as well, depending on what course and what order we're doing things in. You may or may not have dealt with these so far. Both online and my classes have dealt with Cramer's rule and determinants. My class on ground has dealt with Gaussian elimination. I'm not sure about all the other sections. It is not on the online midterm for the online Math 80s, though. You might have a word problem. So if you say how many of each and you have dimes and quarters, and I think there was nickels too. Where was the other one? Yeah, dimes, nickels, and quarters. Then you need to have three equations to deal with the three variables. So we had one in terms of the number of coins. There were a total of 16 coins, number of nickels, number of dimes, number of quarters. And I know the variables stand for the number of them because that's what the question part says. How many of each coin? That's where you get your variables. So this question here told me that I was going to use those as my variables. Be very specific. It's the number of, not the value of them. It's the number of. So my number of coins, number of nickels plus number of dimes plus number of quarters is 16. The value, total value, means we're adding up the values to be $1.75. I did it in terms of cents, so I converted the dollars to cents. That way I didn't have to deal with decimals. So 5 cents per nickel, per meaning times. 10 cents for each is another way of thinking it, for each dime. 25 cents for each quarter. They add up to 175 cents. And then there was one other statement here that says the number of dimes, so that's D, number of dimes, is equals 1 more than twice the number of quarters. Number of quarters is Q. So 1 more than twice the number of quarters. Dimes is 1 more than twice the number of quarters. And then I use substitution method for this rather than elimination because it says D equals. Whenever you have D equals or X equals or Y equals, you can substitute it in. You could also rearrange this into standard form and use elimination if you would prefer. So from there, you have your system of three equations to deal with, and write your answer for word problems in a sentence. So that's a little bit on the systems of equations. And now we're going to do a little review of Chapter 5 stuff on polynomials. So you can add, subtract, multiply, divide, and solve polynomial equations and expressions. So here we would need to multiply, distribute, multiply by distributing there. We want to multiply before we add or subtract, before we combine our like terms. So x to the third, it's only 1. For x squared, we have, take the sign with you, we have negative 9x squared. For x's, we have negative 10x. For constants, we have negative 3 plus 6 is 3 plus 20, so it's 23. For multiplying, we can use box method or FOIL method if it's a 2 by 2, or it's called distributive method in general. I'll show FOIL first. F, so first times first. So 3x times 5x, 15x squared. O, outside times outside. 3x times 2 is 6x. I, inside times inside. Sometimes people call it inner. And then last for L, FOIL. -4 times 2, -8. And then you combine your like terms here in the middle. I have like terms. This next method I'm going to do is just an option. I'm just going to show that you can use a box to organize it. When I first started teaching as a high school teacher, this is the method that we typically use, especially when it becomes like a 2 by 3 or anything higher than that, where FOIL's a pretty nice acronym to use, but it only works for a 2 by 2. Otherwise, you need to do distributive property, and this is a nice way of tracking all your things. So multiplying 3x and 5x gives you this box, 15x squared. There's -20x. These two give you 6x, and these two -8. You're multiplying to get the inside elements. And then here, these are like terms, and so they can be combined. So you still get the same answer, 15x squared, -14x, -8. It's just another method for tracking your distributive property. Number 10 here is not 4x squared minus 9. It is tempting to think you can distribute, but you cannot apply like distributing the exponent to terms only if they were factors. So a, b to some power would be a to some power, b to some power, but not if it's a plus or a minus in between. So what does that mean? Squaring means you multiply it by itself. So this is shorthand for 2x minus 3 times 2x minus 3. Once you write it like that, I think it's less likely to make the mistake of thinking it's 4x minus 9. Now you'll more likely do FOIL, F-O-I-L. So we get 4x squared minus 6x plus 9. And combining like terms, we get 4x squared minus 12x plus 9. So that's a common mistake. People jump to a conclusion and just think, oh, I'll square both things. They're thinking of this, but that only works for products, not for terms, not if there's a plus or minus. Okay, so we did a little bit of multiplying right now. So now let's move on to dividing. There's long division and synthetic division. Synthetic division only works if it's x plus or minus a number. It does not work if it's, got some leading coefficient other than 1, or if it's not linear. So it wouldn't work here because of 3. It wouldn't work if there would be x squared plus 2 or something like that. It has to be literally x, 1x to the first power plus or minus some number to use synthetic. You can always do long division. Synthetic is an option that is a shortcut because you don't have to track all of the x's involved. So long division works in all cases. So let's put our divisor down there. All right, so the first one is, how many times does 3x go into 6x squared? In other words, how do we get rid of this and then the x term and then the constant until we have a remainder? So because you're always multiplying like you do with integers to get that value, you'd say 2 times 3 gives us 6, x times x gives us x squared. But you'll have to distribute that 2x to both those terms. So you'll have 6x squared minus 8x. Just like normal division with integers, you multiply and then you subtract. Now, instead of subtracting a quantity like this, you can just add the opposites. Just make sure you do it in a different color or make it more obvious what your signs are so that you know, oh, am I doing the plus or the minus? So 6x squared minus 6x squared, gone. That was the whole goal. That means you did this right. 7x plus 8x is 15x. Bring down the next term. Okay, now 3x goes into 15x how many times? Well, we need 3x times 5 to give us 15. But we'll also have to do the 5 times negative 4. Now we'll subtract that quantity, or add the opposite. Now we have that going away. That was the whole point. That means we did that right. And the negative 18 plus 20 is 2. So this is of a smaller degree than your original one, so it's not going to go in. That is the remainder. So the way you write this is 2x plus 5 plus your remainder over your divisor here. For synthetic division, because you don't have your x's as just as a shorthand, you'll need to put any 0 placeholders that are necessary. So I'll do that with, I'll do number 13 here. So it's missing the x squared term. So we would have 0x squared. So the way you do your synthetic is you put down the coefficients 2, 0, 1, because there's 1x, and then 5. You take the opposite of this so that you can add rather than subtract. So we get to add since we did the opposite. And because we're going to bring down this first one, and the reason for that is it's 2 times this has to get you this. So it's 2 times 1 gets you the 2. So that's why it's always brought down, because you always have a 1 right here. So now we do the same process basically that we did above, but we're only tracking the coefficients, and its placement will tell us, you know, if it's x's or x squareds or x to the third, or if it's a remainder or a constant, etc. So we're multiplying and then subtracting or adding the opposites. So here we're going to add the opposite. So we're going to multiply 2 times negative 1 and then add. Multiply and then add. Then 3 times negative 1, multiply and add. And then multiply. Oops, I'm done. I was such on a roll there. So what does that mean? This means, as I said, this times the denominator has to give you your original problem. So this must be 2x to the second to get you, when you multiply by x, to get you to 2x to the third. I like to think of it, though, from the back. That's your remainder. There's your constant. There's your x. There's your x squared. You can do one less than your original and work your way down. So your answer would be 2x squared minus 2x. Welcome back, Carly.
Yeah, it keeps kind of jumping me around.
Well, you can go back and watch the recording of any of these that you feel like you want to see again.
I will be.
All right, so that is now we did the multiplying and dividing. Now we're just going to do a bunch of factoring with our polynomials. So we're going to do factor by grouping, which is when you have 4 terms, or is used when you have just 3 terms when your leading coefficient isn't 1. So let's do that. So the process says cut it in half, factor each half. So 4y, x minus 3 is left over, plus 5 comes out in a, so 5a, and then we need x minus 3. Then we factor out the common factor, so x minus 3. And so if we factor it out, then what's left is 4y plus 5a. So here is x minus 3 times 4y, and here is x minus 3 times 5a. And again, this gives you this, so these are all equivalent as you go from one line to the next. You can double check your work by foiling, and it should get you that. So on these, you can always check your work when you're factoring, just foil it or multiply it out, and you should get the original problem. So as you saw earlier, when your A is 1, it's what multiplies to your C and adds to your B. It's really A times C, but A is 1 in this case, so 12. So what multiplies to 12 and adds to 7 is 3 and 4. Since A is 1, I like to think of it as A is 1 and you're done. So it rhymes, and it's true. You just use those for your factorization. You have to be a little bit careful when you have negatives. So 1 times negative 10 is negative 10. Negative 3 goes down there. What works is negative 5 and positive 2. You have to make sure that when you're looking at your options that you are looking for it to multiply to a negative. So 1 is positive and 1 is negative. And if it's adding to a negative, the bigger number has to be negative. And if it's adding to a positive, then the bigger number has to be positive. So again, A is 1, so all I do is steal those values for my factorization. When A is not 1, then you have to do a little bit more work, as I mentioned. You'll have to separate that middle term and do grouping. So here is an example of that. There's no GCF, so I'm stuck with the A of 10. So I'm going to do A times C and put my B down there. Figure out what works for that. And negative 15 and 4. And I do expect it to take longer for you, especially for anyone, especially if you don't have all your factors really honed in. Having a multiplication table and being comfortable with that will help with all this factorization. So I am breaking up this negative 11x in that way so that I will end up with 4 terms and can use grouping. So here it is. This is 10x squared. Then I'm going to, instead of saying negative 11x, I'm going to say negative 15x plus 4x and then minus 6. So these are exact same expressions, but it's broken up in a way that's now factorable. So when I cut it in half, be careful if this had been a negative that you watch your next sign because it has to distribute correctly. So if this is a negative, then you're factoring out the negative and then you'll change the sign. These should match, and they do. If they don't match, it means either you made a mistake or it can't be done with grouping. You can quickly double check your work. Yep, that is that. The one underneath it is a difference of squares. So I'm noticing that this has 2 terms. So my options when I have 2 terms is difference of squares or sum and difference of cubes. You always look for a GCF, and you know sometimes things can't be factored. So keep that in mind as well. So this has 2 terms. It is a difference and it is squares. So the difference of squares formula says take what was squared there, take what was squared there. One has a plus and one has a minus so that the middle term cancels. So you'll end up with negative 7x and positive 7x, so no x's. Technically, you can also use your x here and just put a 0. And there you go, same answer. It's just a lot more work if it would have been like a 25x squared, because then you would have had to have done this with the 0 and remembered the 0, and then you would have to do the grouping and all that. So if you recognize it's a difference of squares, it's a lot quicker. So if I had something like 25y squared minus, let's see, 64. Then I could say it's 5y plus 8, 5y minus 8, rather than having to multiply 25 and negative 64 and then add to 0, because the b is 0, and then do grouping. Oops, that wasn't showing. So again, something where the a is not 1 and it's a difference of squares is a lot quicker to do by recognizing it's a difference of squares. All right, here's two more with two terms. And no GCF in either. I can't pull out anything from either of those. There's no common thing. So I'm stuck with those two-term things, but it is a difference of cubes because this is 2x being cubed. And the way you can do that is either by testing or writing down a list of cube numbers, 2 times 2 times 2, 3 times 3 times 3, 4 times 4 times 4, etc. Or the cube root button in your calculator, or the nth root or x root button in your calculator. So depending on what calculator you're using, there's different buttons for that. And so then 5 times 5 times 5, 5 cubed is 125. So the rule for a difference of cubes is a minus b, a squared plus ab minus, plus b squared. And if it was a plus, which we would be doing on the one below, then that would have been a plus there and a minus there, but it's always a plus. So for plugging it in, that's all we have to do now that we've figured out what was cubed and what was cubed. So we're going to have 2x minus 5, and then we're going to square the 2x. So 2x times 2x. Make sure you are squaring the whole thing, the 2 and the x. So 4x squared plus a times b, so 10x, and plus b squared, so 25. You should check if there's a way to factor this. The way you do that is, again, 4 times 25, 100, and then 10, nothing works, that's prime. And so that's why you can't go any further. There's nothing here with these two terms. It's not a difference of squares or some difference of cubes. It is just a binomial. So we do a similar thing. The signs just are a little bit different with this one because you'd be doing plus, then minus, then plus. Number 20 is mentioned here because of being able to factor out a common factor of 2. And what's nice now is that it looked like I had an a that was not 1, but when I'm factoring my trinomial, the a now is 1. So it's just 14, negative 9. What works? It's positive and negative here, so both of these are negative. And 7 and 2. So x minus 7, x minus 2. This 2 is still a factor. It comes straight down. This next one is here because it's a nice reminder of grouping. It's got 4 terms, but also about factoring as far as possible. So x squared can come out. Here's that negative 9. So then x plus 2, because you have a negative times the positive to get you your negative. That's also great because now those two match up. So I can factor it out. And so it's like, oh, great, I factored it. But you're not completely done yet because there is a difference of squares right here. what was squared, 1 has a plus, 1 has a minus. So completely factor in order to get full credit. Let's see. We can also solve quadratics using factoring techniques because anything times 0 is 0. So on this problem, this one has a common factor of 2m. And then I would see if that can be factored further. We did this or similar one earlier. I think it might have been the same one. A is 1, so we can go straight to m minus 3 and m plus 1. Double check my work. Yep. And now each factor has to can be set to 0 to make the equation equal to 0. So any m can be a solution if it makes the expression equal to 0. So if this is 0, I'd have 2 times 0 times negative 3 times 1. But anything times 0 would be 0, so I'd have a solution. If I make this equal to 0, so 3, so I'd have 2 times 3 times 0 times 4. Well, again, anything times 0 would be 0. So m could be 3 and make that expression 0. And m could be negative 1. So I have 3 answers. It's interesting that the you'll learn this, and it comes up more later, but the exponent, the highest exponent, actually tells you how many solutions your problem will have. Sometimes it means you're going to have 2 of the same, but essentially I have 3 solutions because it's a third degree polynomial here, so 1, 2, 3 solutions. The next one is just a reminder of how, again, to deal with fractions. Multiply by the LCD, 10 to 5, that'd be 10. We'd have 3w squared minus 5 equals, that goes in 2 times, so 14w. And then get it equal to 0, so I'm going to subtract 14w. Then I'm going to factor. I have an a that's not 1, so when I factor, I'm going to do my scratch work over here. 3 times negative 5 is negative 15, negative 14, negative 15, and 1. Grouping. Oops. Because my a is not 1, pull out a 3w, w minus 5, pull out a 1, w minus 5. So this factors to w minus 5 as the common, and then 3w plus 1. Set this equal to 0. You'd have 5 when you add 5 to both sides. Set this equal to 0, subtract 1, divide by 3, negative 1/3. And then last but not least on this midterm review is another word problem. The length of a rectangle. Make sure you're drawing a rectangle. Draw the picture if you can for word problems. The length, so I'll call length L, and the width W, because it's referring to length and width. The length is equals 2 meters more than twice the width. So twice the width plus 2 meters. 2 meters more than. The width is just the width. So we have the width in terms of width, and we have the length in terms of width. And the area is 84 square meters. So find the length and the width. So you have to come to the table knowing the area of a rectangle is length times width. Plug in 84 for my area because that was given. The length we'll do, we'll plug in 2w plus 2. And we're going to multiply that quantity, so it has to be in parentheses, times the width. So we're going to have to multiply both of these by w. Oops, 2w squared plus 2w. Now, when I go to solve this, I can make use of the same technique I had just up above, and I really prefer when I'm factoring to have my leading coefficient be positive. So instead of subtracting 2w squared and subtracting 2w and making this side 0, I'm going to subtract the 84 from both sides and make this side 0. So, and if you don't like it there, you can just say equals 0 there. I'm going to factor out a 2. And I'll go ahead and just switch the equals 0. It's a little bit more comfortable for some people to have it over on that side. And then I can further factor this. 6 times 7 is 42, so if I make that positive 7 and negative 6, a is 1 for what I'm factoring right now. W plus 7, w minus 6. So what makes that 0 is if w is negative 7. What makes this 0 is if w is 6. Now, you have to keep in mind the context. We're dealing with a rectangle and length. So you cannot have a negative length. So you're going to cross that off because it is extraneous, meaning it's a fake solution because of the context, because of the situation. So we know that the width of this rectangle is 6. To find the length, we just plug in the width into our equation. Length is twice the width plus 2. And then answer in a sentence. The rectangle's length is 14, and that was meters, and the width is 6 meters. So I say what I'm measuring, width or length, how much, the 14 or the 6, and in what unit, meters. All right, so any other general questions regarding the chapters 4 or 5 or the midterm?
Just one. Why don't we only use the least common factor in some situations, but the greatest common factor in others? Like, what determines that?
So you use the least when you're trying to, let's see. So the greatest common factor is used when you're factoring things out to make things smaller. So you're using the greatest common factor when you're factoring, because you're trying to get this to be as small as possible. But you're using the greatest, let's see, the lowest common multiple when you are trying to make an equivalent expression that, again, uses the smallest possible. So it just depends which direction you're going. So if you're factoring, you're going to try to factor out as much as you can. But when you're solving, you're going to use the biggest one so that you get rid of all of the denominators. Because if I just use 5 or 2, I'd still have a fraction. So I guess the main thing to keep straight is when you're factoring, take out the GCF. Otherwise, you're going to use the lowest common to get integers or to get common things. So like for fraction or decimal problems, use the LCD, or when you're doing these systems, you want the lowest common, so you have to multiply to get the lowest common, and so you look for the lowest common one. You can get a bigger one, it's just that then your numbers are all bigger. I don't know, does that answer your question?
Yeah.
Okay. That's a good question. Anything else?
Nope.
All right, I'm going to pause the recording, and then I'm going to continue on with the chapter 6 stuff. Did you want to stay for any of that, or?
Yeah, I'm going to stay for it.
Okay. My husband will come home with my kid in just a minute, probably, so you might hear that noise. Let's see. Let me